What is differentiation? Differentiation is method of finding the derivative or rate of change of a function. The rate of change of function is defined as dy over dx equal to fx equal to y. Technique of differentiation. First, constant rule. The derivative of a constant rule states the derivative of constant, which is number. The derivative is equal to 0. Second, power rule. Power rule used to differentiate powers of x. Third, sum and differences rule. When functions are added or subtracted, we can differentiate each term separately. We can differentiate each part one by one. Number 4, product rule. Product rule used when two differential functions are multiplied, like y equal to uv. Number 5, the chain rule, a technique for finding the derivative of composite function. It used when a function inside another function. Number 6, quotient rule, used when one function is divided by another.
For question number 2, find dy over dx for the following function. A. In bracket x power 4 bracket cos bracket 2x minus 5. For this question, we can use the product rule, which is in bracket x power 4 bracket will be u, then cos 2x minus 5 bracket will be v. Then let u equal to nx power 4, and then u prime will be 4 over x. After that, v will be cos bracket 2x minus 5, which is we will know cos derivative of function. We can use cos derivative of trigonometric function. As you can see, cos will be negative sign, so v prime will be negative sign bracket 2x minus 5 bracket, and then we will multiply by the derivative inside the bracket, which is 2. And lastly, the v prime will be negative 2 sign bracket 2x minus 5 bracket. Step 2, substitute into dy over dx, which is the formula is dy over dx equal to u v prime plus v u prime. After we substitute, it will be in bracket x power 4 bracket 2 minus 2 sin bracket 2x minus 5 plus cos bracket 2x minus 5 bracket 4 over x bracket, and then we multiply, and the final answer will be negative 2 in x bracket sin bracket 2x minus 5 bracket plus 4 cos bracket 2x minus 5 bracket over x. Second, for the big question, y equal to 3x power of 2 minus 2 over sin x. We will use the quantum rule. As you can see, 3x power of 2 minus 2 will be u, and sin x will be v. Same as before, let u equal to 3x minus 2, and u prime will be 6x, because the 2 will be constant, the constant will be disappear, so 3 over 3 will be multiplied 2, and then it will be 6x. For v, it will be sin x. Same as before, we can use the derivative of trigonometric function, and then the v prime will be cos x. After that, we will substitute everything into dy over dx formula, which is dy over dx equal to v u prime minus u v prime equal to v power of 2. And then after we substitute, it will be bracket sin x bracket 6x minus 3x power of 2 minus 2 bracket cos x over sin 2x sin power of 2x. And then the final answer, it will be 6x sin x minus 3x power of 2 minus 2 cos x over sin power of 2x. We can write this term into another to make this expression look screen, and then it will be 6x sin x minus cos x bracket 3x power of 2 minus 2 bracket over sin power of 2x.
Question number 3. Given a in power of y plus sine square in bracket x cubed plus ln y equals to 4xy. Find dy over dx using implicit differentiation. Implicit differentiation is used when y is mixed together with x, and we can easily write y over something. So, the most important thing is we need to multiply all the terms with dy over dx. For the step 1, we need to differentiate on both sides, because differentiate every term with respect to x, so it's going to be d over dx in bracket e power of y plus d over dx in bracket sine square in bracket x cubed plus ln y close bracket equals to d over dx multiplied by 4xy. For the first term, we need to use chain rules. So we are going to get e in power of pi dy over dx. And for the second term, we are going to use chain rules twice. It means 2 times. For the first one, we need to differentiate the square. So we can get sine in bracket x cubed plus ln y close bracket squared. Number 2, let y equals to x cubed plus ln y. So it's fine. We need to differentiate the sine. So we can get 2 sine y cos y multiplied by dy over dx. Next, we need to differentiate the ln y. So we all know that ln y equals to 1 over y. So after differentiate, we can get dy over dx equals to 3x squared plus 1 over y dy over dx. The third term on the right side, we are going to use a product rules. So for xy, we are going to multiply it with d over dx. We are going to get 4x dy over dx plus 4y. For the step 2, we need to put everything together, and then as we can see, we can simplify using double angle identities as we have learned from previous semester, using 2 sine a cos a equals to sine 2a. So for the final equation for step 2, we get e in power of y dy over dx plus sine in bracket 2 in bracket x cube plus ln y close bracket in bracket 3x squared plus 1 over y dy over dx close bracket equals to 4x dy over dx plus 4y. For the step 3, we need to expand the terms that we can expect. For the step 4, we need to move dy over dx terms on one side, which I put on the left side. And step 5, we can solve for dy over dx. So for the final answer is dy over dx equals to 4y minus 3x squared sine in bracket 2 and also in bracket x cubed plus ln y close bracket over e in power of y minus sine in bracket 2 x cubed plus ln y close bracket over y minus 4x, and that is our final answer.
So for the question 4, the formula we use is fx approaching fx prime plus f prime x prime multiplied by x minus x prime. So first we have the equation fx is equal to 4.05 power of 3 over 2 minus 16 over 4.05. We assume x is equal to 4.05. So our x prime is 4. We must take the integer closer to the x. So our x naught is x minus x prime. So the answer for the x naught is 0.05. Second, we have the equation. So we must differentiate to get the f prime. We can use the basic rule, that is power bringing in front and power minus 1. So the final answer for the f prime x is 3 over 2x half plus 16 over x squared. So after we got the equation, we can substitute into our formula. So our final answer is 4.20. That's all.